this better? Whoa.
Okay.
Right. So, netsnmp is, as probably everybody of you knows, is the dominant toolkit to implement snmp on Unix. And it's basically its applications, snmp work, command line applications mostly, and libraries. It's got a master agent, snmpd. It's extensible. You can write modules in C, which are included via the DL open system call. And it's got some other extension mechanisms as well, smarks AgentX in particular. It's a C AP. It's got its template generator MIP to C, so you can, if you're focused on C, you can just give it a MIP, and you will just call MIP to C on it, and it will generate a template for your own agents, so you don't have to write everything yourself. You just fill in the missing pieces, etc. But it's C, obviously. And well, the agent architecture it uses internally is beyond this talk. So why Python? My experts told me so. Plain and simple answer. Could have been Ruby as well, but so it came Python. netsnmp comes with a Python module, netsnmp, Do. It's quite a large pile of C code that abstracts the whole C API into an object-oriented approach, but it's client code only. So if you want to do an agent, you're stuck. So basically, the idea is we just take the C API and we access it from Python with C types, imitating AgentX subagents written in C. I'm not the first one to have had that idea. There's a module on SourceForge called Python AgentX, but it had some design issues and it looked rather orphaned to me. I did some patches initially, but after seeing them not being considered for weeks and months, I just thought, well, dump the whole shit and rewrite it myself, so I understand it. Which is, of course, an attitude which is well known among developers. Just do it yourself. Hello, Python netsnmp agent. It's pretty simple, actually. It's just two source files. One has all the C-type stuff, which means prototypes, as we would say in C, which wraps the API called, just 13 kilobytes. And then on top of it, there's netsnmpagent.py, which is the file with the classes. We'll see about that. And it's also not quite large. But it's extensively commented, which explains why the real code size is 1/3 less. I've got example MRBs and agents included. What I mean coding style, it's not particularly PEP8 or whatever the Python coding style proposal is. It's more or less my own coding style, but it's consistent. And it's been tested with both 5.4 and 5.7 versions of netsnmp for the simple reason that it was targeted at enterprise Linux distributions, as they call themselves, SUSE and Ubuntu. And they're still shipping 5.4, so I have to take care of those as well. Let's look how we would implement an MIB. This is basically the ASN notation, how you construct MIBs. You just give it a name. You just tell it a data type. In this case, it's an unsigned 32-bit scalar value. Max access, etc. is not so important right now. You give it a description, and you give it a reference where in the SNMP MIB tree you want this object to appear. So this simple scalars 1 translates to something like .1, .3, .6, etc. This is a quite simple example. It's just an integer value which we want to make available. You could have, you can also do tables, but that's way more complex. But it's supported, of course. So if you have an MIB like this is merely a declaration. You're just saying, you're just merely constructing a tree of information. You don't have the code yet. And that's, of course, the intent of using my Python netsnmp agent module. So you write some Python code, you put an import statement in it, and you just import the one file with the classes, not the API calls. And you construct a new object of type netsnmpagent, which needs an agent name, which netsnmp requires internally. And you give it a list of MIP files. In this case, the MIP file we just defined. netsnmp requires that, for example, so it can translate internally between symbolic names and the numeric OIDs we've just seen. And so you create an agent object. Of course, you do proper exception handling, unlike here. Next thing you do, just because you've declared a structure in the MIB file, doesn't mean that all those information elements have been appearing magically. You still have to explicitly register them, which makes sense because you could have two agents implementing different parts of one MIB file. So you come up with a registration. I've got sort of a class factory here for the different data types. In this case, integer 32. I thought it was unsigned, right? Egal. Whatever. And you give it the OID where this integer should be registered below. So inside your MIB tree. Once you've done that, you've registered all your SNMP objects. I'm speaking of SNMP objects because you could just as well register a table. A table is basically rows and cells of simple scalar values. Once you've done that, you call agent start. That makes it actually connect to the master agent, snmpd. Of course, you do proper exception handling again. And then your agent basically looks like this. This is a simple example, of course. You've got an endless loop. You call agent check and process all the time. This is, in fact, a netsnmp library call. They designed it this way, and as I said, I'm just wrapping their API calls. So we have to do it this way as well. This example, I could, for fun, update the integer value I just declared and double its value all the time, provided I would have initialized it, or give it its value or whatever. And I could call an snmp set from the command line and see the new value appear here. This is very simple. There are, of course, more complete examples, for example, of tables in the source distribution. And the real-life agent is, of course, also much more complex. So the agent I wrote for internal use is like 120 kilobytes, 3,000 lines, because you want to do all the fancy stuff like demonizing and logging and whatever. Right. If I have time, I'll do a short demo in a second. Just so you know, there's some things missing, of course. Notifications and traps in particular. So you can't, as of now, you can't write an agent which informs the master agent, for example, of a fan failure or anything like that. API documentation, who would have thought that? And maybe some unit tests. Because as I said, after all, we produce safety, right? So it would be, of course, nice to have the elementary software modules have safety as well. I'm going to give a real short, quick demo. This is the examples directory of the source distribution. And I've got the simple agent here. If we look inside, this is all the things we just saw, basically. Scalar values, different data types, and also tables. And the nice thing is you just run the script. It sets up everything necessary to test the whole thing, like calling snmpd is isolated from the rest of the system. So you can actually run it with a system-wide snmp instance running. It even says at the top what the commands you have to run. And it dumps the current values of all those variables. And so I can go ahead from separate shell, just give it the command like take this MIP I have in this directory, connect to the instance on this port, because as I said, it's separate from system-wide snmpd. And it gives me the values. And I can do things like I can also access the tables. If I had the right OID, that's first table, all right. So this example, it's on, should be temperatures or anything like that. And I could play around with snmp set as well. But because my time is up, questions?
How much overhead is there compared to implementing an agent in C?
Sorry?
How much more overhead is there in Python netsnmp agent than there would be implementing an agent in C?
In terms of what? In terms of...
Repeat the question.
Yeah, the question was how much overhead Python implementation would be compared to C. In what terms? You mean in like one speed or?
Well, we currently use netsnmp agents as a base to our product, and I'm thinking of re-implementing it in Python to simplify some of the agents. And we can be doing up to 100 to 200 requests per second.
Yeah.
I mean, is there a lot of wrapper around the C API, or is it just fairly bog standard?
It's basically it's a wrapper. It's very close to the C API. So if you have ever delved into the details of the C API, you will recognize much of it. Then again, as you saw, it's pretty abstract. You just create an agent object and register some variables, and you're done. As for the overhead, I haven't benchmarked it for the simple reason that writing the same in C, the same agent I had to write, was no option. So I have no comparison. But overall, I haven't seen any performance issues so far, because Python is actually quite fast.
We're running out of time because the next talk has to start. So thank you, Peter.
Come to me afterwards.
And any questions? Any questions? Chase him out outside the room. The next talk will start just in a couple minutes. Microphone.